Okay, guys, good morning. Happy Friday. Here we go. Let's begin the next section, which is section number 4. So let's pretend that we are in T108, right? Taking notes like usual. So section 4 is going to be on vectors and polar functions. Okay, so let's run this lesson 15-20 minutes, and then Monday, your solo quiz will be based on everything that is in this video. Okay, so section 4, vectors and polar functions. Today we'll just focus here on vectors, just the basics of what a vector is. And then of course Monday, solo quiz number 2. So what is a vector exactly? So let me give you a definition and then we'll explain this. So let's go with a vector is a mathematical object that has a direction and a magnitude. Okay, let me get out of the way and sort of proofread this while you guys copy. Let's see, a vector is a mathematical object that has a direction and a magnitude. Cool. So I want you guys to think of a vector as, I guess, sort of like an Uber. What does an Uber do? An Uber picks you up wherever you are, and it takes you to a certain location. That's kind of what a vector does. But a vector is kind of limited. Like an Uber can go in all kinds of directions at weird angles. Nuh-uh. A vector can go left, right, and it can go up and down. So for instance, you don't have to copy this if you just watch if you want. So think of a couple of numbers, let's say 4, and then a comma, and then a 3. But what I'm gonna do is instead of parentheses, I'm gonna put like little alligator mouths, like a little sideways V, okay? Not parentheses, no, like little V's, sideways V's. When you see this notation, that is indicative of a vector. So here's how I interpret this, okay? So wherever I am on Earth, this vector is gonna come along, and for my current position, wherever it may be, this vector is going to move me 4 spaces to the right, and then it's going to move me 3 spaces up, and then I get off the ride. Done. What if it said this instead? So wherever I am, this vector would have moved me 4 spaces to the left, and then 3 spaces up. This vector would have moved me from my original position 4 spaces left and then 3 spaces down. That's how you interpret this. The x component is always horizontal, either left or right, depending on the sign. And this guy, it's an up or down. It's a vertical movement, depending on its sign. Okay? So that's, in a nutshell, what a vector is. So now why don't we get this off the board here, and let's do a couple of examples. Okay, so pencils back up here. And let's say the directions are something like this here. State the components of vector, and let's just pick a couple of letters randomly from the alphabet. How about we pick the letters, let's say P and Q, okay? So state the components of vector P. So use a capital P, use a capital Q. Now I want you to draw an arrow that goes in one direction like that, and let's put a period there. And actually, let's put a comma, and then let's say where, and then let's say P equals, let's say something like -2, 5, and let's put a comma, and then let's say capital Q, let's go with, how about +3, and then let's say -1, period. So I want you guys to tell me the components of the vector PQ, where P and Q are a couple of points. You see, this is a point because it's in parentheses. So is this. This is also a point. Now this vector, it begins with P and it ends with Q. So the order of the letters so totally does matter. We begin with P and we end at Q. So maybe it could help us if we sort of just went to the X and Y axes. You don't need like perfect graph paper, just make a rough sketch of this. So vector P, or point P rather, point P is like right there. And then point Q would be, I don't know, somewhere like right here. Okay, so this guy is at -2, 5, and this one here is at 3, -1. So to decide the components of the vector, maybe we can actually draw the vector. So draw a array, if you would, or really just like a line segment from P to Q, but make sure that you put sort of like a little arrowhead there. Now, I do want you to understand the context. In this chapter, this arrow does not mean that we go on forever in this direction. No, no. The only reason I drew the arrow is so that you see which is the beginning and which is the end. So this is the beginning because it doesn't have the arrow, and this is where we get off the Uber because this is where the arrow takes us. So that's the only purpose of this guy. Don't think that it goes on forever because it doesn't. So what's the answer here? The answer is going to be PQ with the little arrowhead equals, so let's build our answer over here. So I want you to tell me the components of this vector. So why don't you guys open up the notation for a vector, like the little sideways V's with a comma in between. Now, consider your picture. Always describe first what happened horizontally. To go from P to Q sideways, how much did you have to move to the side? Well, you went from -2 to 3, so that's to the right, of course, 5 spaces. So this is going to be 5 right there. And then how much did you have to drop down to go from a height of 5 to a depth of -1? Well, that's a droppage of 6 units. So for that reason, I'm going to put -6. And this would actually be the answer, because this describes to the reader that we moved 5 spaces to the left and then 6 spaces down. So done, 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 100%. I want to make a comment though. Notice that your final answer, it does not tell you where you began. It doesn't tell you where you started, nor does it tell you where you finished. All the vector does is summarize the motion that you just felt. Here I felt a motion of 5 spaces to the right and then 6 units down. That's all the vector does. It describes how your journey was made, right? Not where you began nor where you ended. Okay, so let's get this off the board, and let's do now, I suppose, a direction. Now let's discuss the direction, and we can also discuss the magnitude, okay? So another example, the directions would be something like state the direction and magnitude of, and let me give you guys a vector here. So I don't have to give it a name, I'll just give you the components. So how about we go with something like, let's go with 8, comma, and let's go with a negative, how about a -3, period. Right, you see something like this on your solo quiz, how the heck do we do this? How do I state the direction and the magnitude of this vector here? Well, I don't exactly know where I am originally. Like, I don't know where I began, but I don't really have to know. All I know is that from wherever my current location is, I'm going to move 8 spaces to the right and then 3 spaces down. So why don't you actually go to the XY axis? And why don't we put a point at the origin? So let's say that we are like right here. That's where I begin, okay? Now this vector Uber, it's going to take me 8 spaces to the right, but then it's going to take me 3 units down, right? 8 to the right, and then 3 units down. So I'm going to get off the ride like right there. So a summary of my trip would be that there. That's what this Uber did. 8 right, 3 down. Now, let's get the magnitude out of the way. That's usually the easier part. So for the magnitude, you have to tell me the actual straight line distance between where you began and where you got off the ride. And in order to find this magnitude, I suppose we can just call this R. Just pick a letter, really, doesn't matter. To find this guy, notice that we can simply go to the Pythagorean Theorem. Because in this triangle, this is 8. Call that -3 if you want to. Let's go Pythagorean Theorem, And the hypotenuse plays the role of the magnitude of this vector. So we can go something like 8 squared plus negative 3 squared equals r squared. And 64 plus 9 is 74 minus 1, which is 73. And then we can square root. And guys, just totally leave it like this. The square root of 73. That's what you call the magnitude. Basically, the length or the distance between where you began and where you got off. Okay? That's the magnitude. Now, your direction is something different. So your direction is like an angle, right? But it's not this angle. No. It's not this angle. No. Nor is it this angle here. Rather, your angles are always measured from due east, moving in a counterclockwise direction. So really, our direction is going to be from the x-axis, counterclockwise. I need a new marker. From the x-axis, counterclockwise. So touch the x-axis and draw counterclockwise until you hit your vector. That blue, that's your direction. So how can I find the blue? Maybe what we can do first, guys, is maybe we can find this little baby angle theta. Let's find this cute little baby angle theta, and that's going to help us to find the blue arc. So to find theta, why don't we go to Sohcahtoa? Why don't we use a tangent model? So let's go with tangent. We know that tangent of theta, tangent is opposite over adjacent. So this would be negative 3 over 8. And I want theta, so what we can do is take the tangent inverse of both sides. And I do have my Casio here next to me, so why don't you guys type this in? And let's see what we get in degrees. Tangent inverse of negative 3/8. My calculator says, check this out. My calculator says about negative, let's call it 21 degrees. Now, calculators are kind of blind. They don't really see what you and I see. You know why the calculator said negative? I'll tell you exactly why. Calculators are kind of lazy. You see, instead of doing, if you want to point at the blue, you can move the purple. If you want to point in the purple direction, you can kind of move counterclockwise like that, the long way, which is the blue, or you can be efficient or lazy like the calculator, and instead of going counterclockwise to point toward the purple, you can just go like this, watch. You can just drop down 21 degrees and be pointing in the same purple direction. But we like to define angles from this position going counterclockwise. So this angle theta, the reason the calculator said negative is because the calculator went clockwise. But no, we do things counterclockwise. So what I want you to see is that the size of this angle is really just 21 degrees. The reason it's negative is because this is the direction. But this is 21 degrees. So what does that tell you about the purple, or rather the blue? The blue is going to be 360 minus 21, because the blue is almost a whole revolution. It's just a little bit short of a full spin. How much short? About 21 degrees short. So take that from that, and our direction would be, what would that be? About 339 degrees. Okay? So the magnitude is kind of easy. It's just Pythagorean Theorem. And the magnitude is always positive for now. The magnitude is always going to be positive. But the direction, you have to be careful where you are. Sometimes you're in quadrant 4. Sometimes you're in quadrant 2, 3, 1. It just depends on where you are. So I do want to do one more, and then I'll let you guys go and just catch up with all your homework. So final answer, this is our direction, and this is our magnitude. So let me check the time. How are we looking with time, folks? We're looking pretty good. Let's do one more, and then I'll let you guys go. So let's get this off the board. And I suppose we'll keep the same directions. Let me just change this vector, yeah? Let me change this vector. Let's get this off the board here. Yeah, so guys, this is the stuff we're going to learn next week. Monday and Tuesday, we're going to learn vectors and polar functions. And then Wednesday and Thursday, we'll learn new stuff. So this upcoming week, it's like all going to be brand new stuff, like all of it, the whole week. So be ready for that. So how about this time? Our vector is, let's say -4, and let's go with like a 7. So let's make a model of this. So -4, 7, let's say this is -4, and let's say this is 7. So that'll take us like right there. Like right there, okay? Yeah, because it's 4 to the left and then 7 up. So what we can find first is our magnitude. Let's call it R. And let's go Pythagorean Theorem to find R. So we know that this is -4, and we know that this is 7. So go Pythagorean Theorem. So we'd have like 7 squared plus, in parentheses, -4 squared. So this is 49 plus 16. What is it, like 65 for R squared? And so R would be the square root of 65. So this is our magnitude, right? Now we have to find our direction. So for that there, maybe we can first find this cute little baby orange angle theta. There it is. Let me try that again. I think that's kind of hard to see. This guy here. First, let's find the red angle. So to find the red one, we can go tangent, right? It seems like there's a lot of tangent involved here. So we can go tangent of theta equals opposite over adjacent. And theta, if you go tangent inverse like we did in the previous video, we can go tangent inverse. And that would be about, let's see, what does this say? This says negative. It says -60, let's call it about -60-ish degrees. But again, when you get a negative, just ignore the negative. Turn it into a positive so you can see really the size of the angle. So this angle here, it's about 60 degrees. But that's not the answer, no way. Because our direction always begins pointing due east, counterclockwise until you meet your vector. So for this blue, how am I going to find it? Well, in this case, this blue, think of it as going all the way to 180. But it stops 60 degrees short of 180. So that tells us that the blue has got to be worth 120 degrees, right? Because 120 and 60 gives you a full 180, which is half a spin. So this is 120 degrees for our direction. So let's jot that down. So our direction would be 120 degrees. So guys, it depends where you are. If you're in quadrant 4, you might have to go 360 minus. If you're in quadrant 2, you might have to go 180 minus. If you're in quadrant 1, it's probably just the angle, period. But what happens if you're in quadrant 3? So what you should do is think about that situation over the weekend. What happens if your vector takes you to quadrant 3? How would you find the direction in that instance?